Teleportation, instantly transporting matter from one place to another. It's a staple of science fiction, from Star Trek's transporters to futuristic sci-fi labs where humans vanish and reappear at will. But now, thanks to quantum physics, teleportation is moving beyond fiction and into the realm of real science. So, is quantum teleportation actually real? Could we one day teleport ourselves across the globe, or even to another planet? Or is this just theoretical smoke and mirrors? Let's break it down. First, let's get one thing straight. Quantum teleportation isn't about physically moving an object through space. Instead, it's about transferring the exact quantum state of one particle to another, sometimes at great distances, using the most bizarre phenomenon in modern physics, entanglement. Quantum entanglement occurs when two particles are so deeply linked that measuring one instantly affects the state of the other, no matter how far apart they are. It's not magic, it's not energy beaming through space, it's information, and it defies our everyday sense of cause and effect. Even Einstein found it unsettling. He famously called it spooky action at a distance. And yet, it's one of the most well-proven aspects of quantum mechanics. Here's how quantum teleportation actually works. Imagine you have two entangled particles. Let's call them A and B. Particle B is sent far away, maybe even thousands of kilometers. You now introduce a third particle, C, the one whose quantum state you want to teleport. By performing a special measurement on particles A and C together, you entangle them and destroy C in the process. But something remarkable happens. The quantum information from particle C gets transferred to particle B even though it's far away. This is teleportation, not of particles, but of their quantum information. It might sound abstract, but this isn't just theoretical. In 1997, researchers at the University of Innsbruck in Austria teleported the state of a photon across a small distance in a lab. Since then, the technology has improved at an astonishing rate. In 2017, Chinese scientists teleported quantum information between a satellite and Earth, a distance of 1,400 kilometers. That's not a simulation, that's real quantum teleportation through open space, proving that it can work across vast distances. But before you start dreaming of teleportation booths or disappearing into a sci-fi portal, there's a major caveat. Quantum teleportation only works on very small scales, single particles like photons or electrons. When we talk about teleporting humans, we're entering an entirely different universe of complexity. To teleport a human being, you'd need to perfectly record the exact quantum state of every atom in the body, all 10 to the power of 28 of them. Not just their position, but their energy levels, spin directions, and quantum entanglements with other atoms. And here's the problem. You can't observe a quantum system without disturbing it. It's a paradox embedded deep within quantum mechanics. Measuring all of those atoms would destroy their original. So yes, in theory, you could teleport a person, but the version that steps out on the other side would be a copy, a perfect replica with all your memories, personality, and consciousness. But the original you would be gone. So we're not just dealing with physics, we're walking into a deep philosophical dilemma. If your consciousness is destroyed and rebuilt atom by atom in a new location, is it still you? Would your friends notice a difference? Would you even know? Teleportation then isn't just a technological issue. It challenges our understanding of identity, continuity, and even the soul. Still, quantum teleportation holds enormous promise, especially for communication. One of the most exciting frontiers is the quantum internet. Using quantum teleportation, scientists are building networks where data is transferred instantly and securely. Why secure? Because if someone tries to eavesdrop, the quantum state changes and the system detects the intrusion. It's unhackable by design. A global quantum internet could revolutionize cybersecurity, finance, and diplomacy. And we're not far off. The US, China, and the EU are investing billions into building quantum networks, quantum satellites, and teleportation-based encryption. We're talking about real-world infrastructure powered by quantum principles. Another potential application, quantum computing. Teleportation could enable remote quantum processing processors to share states and entanglements, allowing quantum computers to work together across long distances. This kind of distributed quantum processing might one day power AI systems, molecular simulations, or climate models beyond anything classical computers can handle. But let's circle back. Why does quantum teleportation feel so much like science fiction? Because it breaks the rules of classical intuition. We're used to thinking in terms of physical location and contact. If something moves, it has to travel through space. But quantum physics shows us a reality where information can move without motion, where particles don't just exist in one place, but in superpositions, probabilities across many places, where measurement creates reality. It's a world that's real, testable, and already changing technology, but still completely alien to human experience. And yet, every breakthrough in quantum teleportation brings us closer to understanding, and perhaps one day mastering, the deeper laws of the universe. So, is quantum teleportation science or science fiction? Well, it's both. We're not teleporting people yet. We might never. But we are teleporting quantum information across cities, satellites, and labs. And the tools we're building now may be the foundation for a future we can't even imagine yet. In the quantum realm, truth is often stranger and far more fascinating than fiction. Thanks for watching, and don't forget to subscribe for more stories from the strange, powerful, and mind-bending universe around us.